Hello friends, this video we are going to introduce from recurrent tree to two-dimensional dynamic programming. The problem is EditDistance. We are given two strings. We should find the minimum number of steps to convert those two strings to equal to each other. Each step we have three options: insert, delete, replace. For example, S equals ABCMN, T equals ADEF. We start from index 0, 0 because A is equal to A, so we move index to 1, 1. Then B is not equal to D, so here is our option. Option 1, we replace B with D. We can also, another option is replace D to B. So now they are the same. So we move index to 2, 2 because we have CMN on S and EF on T, so we move to index 2, 2. That's this subproblem. Another option is we can remove B from S, or we can add a B to T to make this part equal. So we have CMN left and DEF left. By doing this, we move index to 2, 1. That's this subproblem. And our another option is here we can remove D from here, from T, or we add a D to S. So by doing this, we move index to 1, 2. That's this subproblem. So for each subproblem, we're doing the same until we reach the end of the string. We can solve this with DFS. Here, this is our DFS solution. We start with post 1 is 0 and post 2 is 0. So if both of them reach the end of the string, we return 0, because if both empty, there is no need to edit, so we return 0. What happens if one string reaches the end and another is not? We just return the difference. For example, if S reached an end but T has 4 characters left, so we return 4. And another one is here, the same. If this one reaches the end and another one is not, we just return the difference of the length. So here is our, if those two are equal, we just move index advance by 1. That's this example here. We move to 1, 1. Now we have option 1, both advance by 1. Optional 2, one stays the same and another advance by 1. So optional 3. Finally, we return the minimum of those 3 options. So that's our DFS solution. The time complexity is 3 to the nth. 3 to the nth, because each step we have 3 options, and the tree reach the end has length of n, the head, or n minus 1. So the sum is about 3 to the nth. If we take a look here, we are repeatedly compute for the same subproblem. So that's remind us we can use DFS cache. So those index remind us for cache, that would be two-dimensional cache. So here is our DFS cache solution. We have two-dimensional cache here. One of them initialized with -1, and one of those are the same with DFS solution. The only difference is here, if the status we already know, we just return the result. Otherwise, we're doing the same optional 1, optional 2, optional 3, and here is the minimum option of those 3 plus 1, because you delete or add or replace. So then we store the result here. So by using memorizing, the time complexity would be reduced to all the m times n. Or previous would be m plus n, because you just feel this two-dimensional array, then you return the result each time. Now, as we already know before, every DFS with memorizing can be converted to bottom-up dynamic programming. We just convert the termination status into the initialized status of the dynamic programming table, and the optional are same. Here, for example, for this example, 0, 0, 0, 0, 0 means empty to empty. If two strings are empty, we have the edit distance would be 0. Then here is t. If s is empty, t, no matter t is what? Here t is a, so edit distance is 1. Here is 2. Here is 3, 4. Because s always empty in this column. So for the same, if t is empty here, s is a, so 1, s is ab, 2, 3, 4, 5. This, though, is the same with this one, and this one, this one. That's the termination status of the DFS solution. So now, because a equals a, so we should come here. We look for the s terminate before a, that's empty, and t also is empty, terminate before a, so the edit distance is 0. That's true, because a and a, the edit distance would be 0. Now we move to T is A, D, S is A. We fill this row. So here we have three options. Option 1 is here plus 1. Optional 2 is use this one or this one. Minimum of those three plus 1. So it's 0 plus 1 is 1. So we can, which means we can add a D to S to make them the same. We just keep doing the same step until we fill the full of the table. So at the end we return the value of this one. So that's our dynamic programming solution. Here we initialize the two-dimensional array with all 0. Then we initialize the each row, first column, first row here. Okay, here is our if the okay, now it's better. If the two characters here are equal, here we just use I-1, J-1. Otherwise we have three options. Here is optional 1, optional 2, optional 3. Then the minimum of those three options plus 1 is the edit distance of each step. Okay, thanks for watching.